Hello, my name is Jen Grantham, and this week's presentation is on IMAPS and DNS. Within this presentation, we will cover IMAPS configuration on Linux using Dovecot and hardening recommendations. As for DNS, we'll discuss configuration on Windows using IIS and on Linux using BIND, as well as hardening recommendations for both servers. First, let's talk about IMAPS. IMAPS stands for Internet Message Access Protocol Secure, with the encryption utilizing transport layer security and secure socket security, a secure socket layer. IMAPS is an extension of IMAP, however, with the added encryption for creating secure communication between client and server. This encryption measures sensitive data, including login credentials and email content, making it difficult for eavesdroppers to intercept the data. The default port number for IMAPS is 993. In terms of authentication, IMAPS utilizes PLAIN, LOGIN, and CRAM-MD5. The authentication ensures only authorized users can access their email accounts. Within our last presentation, we discussed POP3S protocol. And while POP3S and IMAPS are both email protocols for the Linux operating system, the main difference is the email handling when reaching the server. POP3S downloads the email from the server and then deletes it, whereas with IMAPS will download and store the email on the server, allowing it to sync across other devices. This feature of IMAPS allows users to better organize the server mailbox. For configuring IMAPS on the Linux operating system, we're going to utilize Dovecot. Now, we covered Dovecot in our previous presentation, but to give a little more detail here, Dovecot is an open source IMAPS and POP3S email server and is widely used because of its reliability, scalability, and ease of use. I've laid out the steps on this slide to provide the basic IMAPS configuration on the Linux server. The steps mentioned are rather simple. Additional steps are likely required depending on the type of server being set up. The additional steps that you might want to look into are authentication, user management, and advanced SSL and TLS settings. Whereas on this slide we cover editing the Dovecot configuration, configuring the mailbox location, and also how to open the firewall port 993 where IMAPS is located. Some hardening recommendations for securing the IMAPS protocol include utilizing advanced TSL and SSL encryption, implementation of security pinning, and securing configuration files and implement IP whitelisting. Utilizing advanced TLS and SSL encryption within IMAPS is essential for several important reasons, as it significantly enhances the security and confidentiality of email communication. These include data confidentiality, protection against eavesdropping, and added authentication, ensuring data integrity and allowing for secure password transition. As for security pinning is a security mechanism used to ensure the authenticity of TLS and SSL certificate presented by the mail server during the TLS-SSL handshake. The primary goal of security pinning is to prevent against man-in-the-middle attacks and unauthorized fraudulent server impersonation. As for securing configuration files, securing configuration files in IMAPS is crucial for several reasons, primarily related to protecting the confidentiality and integrity and availability of email communication and the email server infrastructure. And lastly, whitelisting the IP addresses in IMAPS or any other service can be a useful security measure depending on your specific use case and security requirements. Whitelisting involves creating a list of approved and trusted IP addresses that are allowed to access the service while blocking all other IP addresses. The allowance of a specific list of IP addresses allows for additional security measures to protect the server. Now we'll move over to discussing DNS. Some technical information behind DNS. DNS, or Domain Name System, is a critical component of the Internet that helps translate human-readable domain names like www.example.com into IP addresses like 192.168.1.1 that computers use to identify each other on the network. Some technical details about how DNS works. You first have a hierarchical structure. The DNS system is organized in a hierarchical structure with a root domain at the top. Below the root domain are top-level domains, TLDs, like .com, .org, .net, country codes, and TLDs like US, UK, and CA, Canada. Beneath TLDs, second-level domains, SLDs, are subdomains and individual host names. DNS servers. DNS relies on a distributed system of DNS servers that store and provide access to DNS records. There are several types of DNS servers, including root servers. These servers store information about the root domain. TLD servers. These servers store information about the specific top-level domains. Authoritative servers. These servers store DNS records for individual domains. Resolver or recursive servers. These servers help resolve DNS queries by recursively querying authoritative servers to find the IP addresses associated with the domain name. DNS records are stored on an authoritative DNS server and provide information about a domain. Common DNS record types include A record, which maps the domain name to an IPv4 address, AAAA record, which maps a domain name to an IPv6 address, CNAME record provides an alias for a domain name, used commonly for subdomains and domain redirection. And lastly, for DNS resolution process, when a user enters a domain name in a web browser, the local device sends a DNS query to a resolver server. The resolver server checks its cache to see if it already has the IP address for the domain. If not found in the cache, the resolver contacts root servers to find the TLD server responsible for the domain's TLD. The TLD server directs the resolver to the authoritative server for the specific domain. The authoritative server provides the IP address to the resolver stores the IP address in its cache and returns it to the local device. The local device can now use the IP address to connect to the web server associated with the domain. For configuring DNS, we'll start with Windows where we're using IIS, also known as Internet Information Services. DNS records must be set up to map to the domain names specific to the IP addresses or host names where the web services are hosted. The steps to configure DNS on Windows is 1. Install DNS server role by opening the Server Manager. Select Add Roles and Features. From here, the wizard will guide you to select the DNS server. After the DNS server role is installed, you will be able to access the DNS Manager via the Server Manager by selecting Tools and then DNS. The forward lookup zone is utilized for mapping domain names to IP addresses. These are created from the DNS Manager by right-clicking Forward Lookup Zones, select New Zone, and then follow the wizard. Select the primary zone and specify if it's to all DNS servers on domain controllers in this forest or the domain. The process is complete by naming the new domain. Once the forward lookup zone is created, you can add DNS records for websites. These DNS records were mentioned on the prior slide. Name servers must point to the DNS server's hostname or IP addresses. These records specify which DNS servers are authoritative for the domain. The DNS resolution verification can occur through using the command line tools like NSLOOKUP or ping from other computers to ensure the domain name resolves to the correct IP address. Now for Linux, we are utilizing bind, also Berkeley Internet Name Domain. This involves setting up the DNS server to manage the domain name resolution for your network. Bind is a popular and robust DNS server software that is widely used on Linux servers. The step-by-step guide on how to configure DNS using Bind on a Linux system. To edit the Bind configuration file, first locate the config file in the specified directory within this slide. Utilize your preferred text editor to open the configuration file. Within the configuration file, the forward and reverse zones will need to be defined. The forward zone maps the domain names to the IP addresses, and the reverse zone maps IP addresses to the domain names. For step 3, you'll need to create a zone data file for each zone defined in the configuration file. The last of the steps will include creating reverse zone data file, validating the bind configuration file, and lastly restarting bind. I've placed some sample code for these steps in the appendix portion of this presentation. And now for the hardening recommendations. We'll start with hardening recommendations for DNS on Windows. Hide DNS servers and DNS information, lock DNS cache, and validate the DNS integrity with DNS SEC. Hiding DNS servers and DNS information can be a security practice employed to enhance the security and privacy of a network. While DNS is a critical service for Internet and network connectivity, there are situations where minimizing the exposure of DNS information is beneficial. The other benefits of hiding DNS server and information include reducing the attack surface, minimizing reconnaissance, and enhancing privacy. For the DNS cache, locking the DNS cache is often referred to as DNS cache locking or DNS cache snooping protection. This is a security measure implemented in DNS resolvers to protect against certain types of attacks and unauthorized data extraction. This is important for a few reasons. Locking the DNS cache can prevent DNS cache poisoning, securing the DNS records, protecting against data leakage, and enhancing DNS security. Lastly, for DNS SEC, validating using DNS SEC, which stands for Domain Name System Security Extensions. This is a suite of security extensions to the DNS protocol. DNS SEC is designed to address specific security vulnerabilities in DNS and provide a way to validate the integrity and authenticity of DNS data. This validation can help prevent DNS spoofing, verify data authenticity, and mitigating man-in-the-middle attacks. Now for hardening recommendations on DNS on Linux. Implementing resource isolation for DNS on Linux is an important security and performance optimization measure that can help protect your DNS server and ensure the reliable operation. Resource isolation involves segregating DNS-related processes and allocating specific system resources to them. By implementing this recommendation, you will mitigate attacks, reduce the attack surface, and likely see some optimization on the server performance. Implementing proper access controls on the DNS server is crucial for maintaining the security, integrity, and availability of the DNS services. Access control ensures that only authorized entities can interact with the DNS server and perform specific actions. Lastly, the principle of least privileges, PLLP, for DNS on Linux is a critical security practice that restricts access and permissions to the minimum necessary for the DNS server and associated processes. The goal is to minimize the attack surface, reduce the risk of unauthorized access, and tampering or misuse of DNS services. On a final note, these are the list of the references that I utilized for putting this presentation together. And lastly, the appendix that I mentioned earlier in the presentation for the sample code for configuring the DNS using bind on Linux.